to pause and make sure that my captions are showing up. Number 4. Okay, so let me should be able to share the screen because I was just using it. Okay, number 4. So we have, let's scroll back. Number 4. All right. If 50 tickets are sold and 2 prizes are to be awarded, find the probability that one person will win 2 prizes if that person buys 2 tickets. Okay. So we're choosing tickets out of a pool of 50, right? And 2 of those are winning tickets. Because there's 2 prizes that are to be awarded, right? So did you try this problem already or not yet?
Not yet.
Not yet. Okay. So this is, so is there something in particular that was confusing you about this?
The wording.
Huh?
The wording.
Okay, so there's 50 tickets. Okay, two of them are winning tickets. Okay, 2 winning tickets because there's 2 prizes, right? That means that the other tickets you're going to lose. Okay, and you're buying 2 tickets. Okay, so you're buying 2 tickets. Now you want to find the probability that, let me go back. You want to find the probability that one person will win 2 prizes if that person buys 2 tickets. So you want to find the probability that one person will win both. Probably pretty small, I would imagine. Let's take a look and find out. So here we're looking at this. We're looking at the probability of winning 2 prizes if one person buys 2 tickets. So what we have to look at is we have to look at the top of this fraction is going to be the number. So this is the number of ways to win 2 prizes, right? So the number of ways that you could win both over the number of ways to choose tickets, right? So these both involve combination rule. So here, okay, so I know we've worked on this and the videos also show this. So we have to think about, okay, how many, if I'm looking at the numerator, right? How many ways are there to win 2, to win 2 prizes? How many ways are there to do that?
$50 tickets.
Well, there's 50. Okay, so let's think about it like this. So when we're looking at combinations, right, which we are, let's do the bottom first. So how many tickets are there in the pool? There's 50, right? And how many are we going to choose? 2 of them.
50. Yes.
Right? So the bottom is 50, choose 2. This is the number of ways to choose 2 tickets, right? But the top is the number of ways to choose 2 winning tickets, right? So how many winning tickets do we have?
2.
We have 2 winning tickets. And we want, if we're going to win 2 prizes, we better choose both of them, right? From the 2 winning, so this part of the answer says there's 2 winning tickets. We're choosing 2 of those. And if you want to put in the other part of it, because I know Professor Nickel does this, you want to choose from the other 48 that are losing tickets, you would write this as 48 choose none, because you don't want to choose from the losing tickets. 48 choose none is going to be 1 when you work this out. So it's not going to change this answer, but it does account for both groups. So from the winning tickets, from the 2 winning tickets, you want to choose both of those. And from the 48 losing tickets, you don't want to choose any of those. So here, when we do this, we have this. And I think you're familiar with how to put it in your calculator, right? How do you feel about that? Do you feel comfortable with that?
Yeah.
Okay, so you're going to put 2, choose 2. So 2, math, probability, NCR. I said it, but it didn't go over there. Okay, there we go. 2, math, probability 2. So 2, choose 2 times. If you want to use, like I said, if you want to use the other portion, you can. So times 48, choose 0.
48.
Because there's 48 losing tickets and we're not choosing any of those. Right? We're just choosing the 2 winning tickets from the 2 tickets that we buy, and we're not buying any from the other one. 48 math, probability, and CR 0. We're not choosing any. That top part comes out as 1, which we know there's 1 way to choose both. Then the bottom part of this is we have 50 tickets, so we're going to say 50. Choose math, probability, and CR3. We're choosing 2 tickets from it. So we get 1 over 1,225. And that's my fraction. If I want the decimal, I can do 1 divided by 1,225. And this is small, okay? Remember, this is not 8. This is 8 with an e to the -4. So that means that this is going to move 4 places to the left. So we would end up with 0.0082 if I rounded to 4 places. This moves over, so it gets 0.00081632 and so forth, right? So if I round this to 4 places, there's a 1 behind it. So this would be, this is a 1. So this would equal 1 over 1,225. And that would equal approximately 0.00081632. 0.0008.2. And if I wanted, but if I wanted 4 places, this would be that 0.0008. 1 over 1,225, and that percentage would be, don't quit your day job for this. 0.00 actually 0.08%. I think the answer that she gives on the key is just the fraction for that one.
It is.
Okay.
Mm-hmm.
Questions about this?
Not really.
No?
I found out how to do it.
Okay, good. All right, let's go on to the next one. How about number 5? How was that?
I haven't tried any of these.
Okay. Take a crack at it and see if some of them are more straightforward than others. Some of them are a little bit squirrely. So let's, I don't remember what number 5 is off the top of my head. Let me see. Oh, this is, yeah, we have to count. It's not hard. You just have to count properly. Encyclopedia Britannica's list of 20 world-class orchestras includes the following from the United States. And they give you a list of the orchestras, okay? Choose 5 at random for from the list of 20 for a benefit CD, okay? So we have 20. Now, do they list all 20?
No.
No. That's usually that's where students get confused. All 20 are not listed. How many are listed?
Only 20.
There are 20, but how many are actually listed in the problem?
5.
There are, be careful there. They have the Boston Symphony Orchestra, that's 1. The Cleveland Symphony Orchestra, that's 2. The Los Angeles Philharmonic, the New York Philharmonic, the Philadelphia Orchestra, and the San Francisco Symphony. I count 6. Is that not correct?
Yeah.
Yeah, I count. Is it 6 or 7? Let me see.
It's 7.
7, right? There's 7.
Mhm.
So 7 of the 20 are from the United States, is what this is telling us. What they gave us was, instead of telling us there were 7 from the United States, they named them all, okay? So the first part of this question says, what is the probability that the collection will include at least one group from the United States? So what we have to do here, we have to use the complement a little bit here. So we have to figure out, we have 20. Let me go to the whiteboard. So let's see. So here, okay. So our orchestra, right? This is problem number 5. Okay. So we have 20 groups, 20 symphony, right? We have 20 symphonies, and we know that 7 of them, 7 are listed as from the United States. Now, this is where splitting up the total will help you when you're finding probabilities. And I think there was one example of this in the PowerPoints, but we don't do this as much, but we do this quite a bit in the problem. So if 7 are from the United States, then it stands to reason that 13 are from other countries, okay? We're gonna need that in a minute. Now, we wanna find some probabilities, okay? What we
Wait,
wanna
13.
find, yeah, because there's 7 from the US, right? And there's a total of 20. So
20 minus 17.
20 minus 7
Or 7.
is 13, right? Does that make sense?
Yeah.
Okay, so now we're going to say this. Question, we have two questions buried in here. The first one is, choose 5 at random from the list of 20. What is the probability that the collection will include at least one group from the United States? So we actually have 3 probabilities buried in here, but one group from the US. So now we're going to say we've done probabilities with at least one before. So we're going to say this. We're going to say that the probability of at least one from the US is going to, we're going to use the complement rule here. Okay, at least one from the US means that we're going to have 1 minus the probability that none of the, remember, we're choosing 5 of them, none of the 5 will be from the United States, right? That's how we're going to set this up. Questions about this part?
No.
Okay, so now, and remember, we're choosing, I didn't put this in the note, but we're choosing 5 symphonies. Okay, so we have 1 minus. Now, if I want the probability that none of the 5 will be from the US, then all 5 will be from somewhere else. So here I have to create a fraction, right? And on top of that fraction, I have the number of ways to choose 5 from outside the US. Okay, which is what I want. The number of ways to choose 5 from outside the US over the number of ways to choose 5 symphonies. Okay, so this is going to be 1 minus. Now, let's think about this fraction. Let's do the bottom first. Okay, so how many symphonies total do I have?
5.
I'm choosing 5. How many do I have to pick from?
20.
Yeah, so from 20, I'm choosing 5, right? So this is going to be, the bottom of this is going to be 20, choose 5. Okay. Now the top of this, we're going to be restricted. And that's why I made this note up at the top. From the top, we're choosing 5 symphonies, but we're choosing them from outside the US. So how many symphonies are from other countries other than the US?
13.
13. And we're choosing 5 of those. So our selection for this first part of the problem is limited because we're only choosing from 13. So it's 1 minus this this quotient. Okay. So let's look at it. Put our calculator on the screen here. Okay, there it is. There's the calculator. All right, so we have, let me clear this out. We have 1 minus, and I'll go ahead and do the fraction first. So I'm going to do, then I'll go back and do 1 minus in a minute. So we have 13 math probability and CR. 13 choose 5, 1287. And we have 20. So we'll do 20 math probability and CR 5. This is going to give us 15,504. So now we have 1287 over 15,504. And I'm going to actually, let me write 1 minus 1287 over 15,504. Let's do that. Let's convert that answer to a fraction. Math. Convert to frac. And we get that answer. 4,739 over 5,168. And if I want to make that a decimal number, right now, because let me go math, convert to decimal just because that's there. Okay, it's not, that's weird. I don't know why. Okay, let's see. 4739 divided by 5168. Not sure why it didn't do that. There's my decimal. So it's about, and if you want to use your mode key and round to 4 places, you can. This is going to go second quit, come back here and hit. That comes out to 0.917. Okay. Now we have a couple of more parts to this. So let me 4739 and 5168. So we have $47.39. $47.39 and 58. So now 51.68. That comes out to 0.917, which is 91.7%. Okay, so this is equal to 91.7. Now let's go to the next part of this question. Let's go back to here. We're going to have, so get, okay, what is the probability that the collection will include at least 2 from the United States? Now this is a little bit harder because we don't have a shortcut for at least 2, okay? So you could subtract some fractions from 1, or you could add a bunch of things together, but I think it would probably be easier to go up. Remember, we're choosing 5. So this one is going to give us this. This is a little bit more, calculation involved here. So we're doing at least 2 from the US. So when you do this part, what we're going to do is we're going to say this. Probability of at least 2 from the US means we have several possible outcomes that we can have. We can have, remember, we're choosing 5. So we can have the probability that 2 are from the US. Let me write 2 US and 3 other, right? Or we can say probability of 3 US and 2 other, or the probability of 4 US and 1 other, or we have one more here, or probability of 5 US, which they're going to ask us in the next question, 5 US and 0 other. Okay, now that's a lot of probabilities to add up. Okay, so you could add up all of those fractions and it wouldn't be awful, but it would be a little bit of work. Or you could subtract from 1 and use the probability of none from the US and 1 from the US. But which way would do you want to do it this way, or do you want to use the complement?
The complement.
You want to use the complement? Okay. So the other way to think of this is to say that the probability of at least 2 from the US means 1 minus, now I have to be a little bit careful here because it's not just 1 minus 2. That's the hard part. That's why I wanted to write this first. So what you want to subtract is the ones we didn't use, which is probability of 0 from the US, 0 US and 5 other. 0 US and 5 other, which you would expect, but it's also Or we have one more term, which is, so it's minus, let me draw. Because we have to calculate this first. We have to calculate this piece first. So 0 from the US and 5 other, and also the probability of 1 US and 4 other. Okay. So now this means we're gonna have two fractions that we're gonna have to put together. So 1 minus, now let's work this out, okay? So we work this out and we want, no, but now remember, we had 7 symphonies from the US total, right? And we had 13 other, the total was 20, all right? So here we have none from the US. So from our US group, we have, this is going to be 7, choose nothing, because we're not choosing any from the US, and means multiply, right? 5 other. So we go to our total of other, we get 13, choose 5, because we're choosing 5 from there. Now the bottom part of this is always,
50
it's
or
always
20.
Yeah, 20, in this case, 20, choose 5, right? 20, choose 5. So the bottom doesn't change, it's the top that changes. 20, choose 5. So now the second part of this, and if you, for those of you who are watching this later, who might have tried it and you didn't get the answer, you were probably missing the second term. So here, we're going to add 1 US. So now we have, remember, there's 7 US. So this is 7, choose 1, right? And from the 13 that are not, we have 4. So this is going to be 13, choose 4, 13, choose 4. Like so. And then again, the bottom is 20, choose 5. So you don't necessarily have to show every single separate combination in here. I would maybe show the separate fractions, but I wouldn't, you don't have to, it depends on how much arithmetic you want to do, but you do need to show this part of the calculation in blue. So now let's go to the calculator here. Did you work on it already, or are you not that far yet?
Hold on, I'm about to.
That's fine. I'll do it too, and then we'll see if we come up with the same thing. So 7, math, probability, and CR. 7, choose 0. It's going to be, oops. 7, choose 0. That would have been a surprise. 7, choose 0 is 1. Now we're going to do 13, choose 5. So we have 13, math, probability, and CR. Oops. What's going on here? I hit the wrong key, sorry. Math, probability. 3. Oops. Oh, I see what I did. hold on, I ended up on the wrong screen. Let me try this again. 13 math, probability, NCR 3. 13 choose 5 is 1,287. Okay. It's so, and then 20 choose 5 is going to be 20. Math, probability, and CR 5. And that's 15. So that piece is the same. Now, if I'm going to choose 1 from that, so I've got, this is 13 choose 5. This was, let me put my fractions down here. This is 15,504, right? And 7 choose 0 is 1 here, times, I'll use the star, times 13 choose 5 was 1287, right? That's the first piece of this. Now, 7 choose 1, you should find that that's 7.
1.
7 choose 1. There should be 7 ways. Yeah, 1 for 7 choose 0. All right. So 7 choose 1 times 13 choose 4. This is 7. Math, probability, NCR 1. That's 7. 13. Math, probability. Oops. 13. Math, oops. Math, there we go. Probability. 3. And I don't know, 13. There we go. Math, probability. 3. 13 choose, what did I say? 13 choose, hold on. I forgot what I said. This is 13 choose 4. So this is going to be 13 choose 4. So we have 7 times whatever 13 choose 4 is. What did you get for 13 choose 4?
715.
715.
Mhm.
Sounds good. Let's do some other arithmetic here. Okay, so that's that. Now let's multiply those together. So we have 7 times 715. You don't need to show every single piece of this arithmetic. I just want you to see where the numbers are coming from. This is 5,005. Okay, so this answer, this part of the answer, I should say, is because we need to do the final calculation. This is 715. And then this is going to be 15,504 down here. So this, now if I do all the arithmetic, keep in mind, we're gonna once we add that, we're going to subtract it from 1 to get our final percentage. So 1 minus this result. So we have 1287 plus this. So what I'm going to do now is I'm going to subtract that. So I have, okay, let's go and do this here. So we get oops, calculator, whoopsie. Undo that one. There we go. Let's go to the calculator here. Come on, screen. My mouse is not cooperating. There it is. Okay, so we have 1 minus parenthesis. This is 1 over. Or no, I'm sorry, it's 1287 over 15,504, right? And I'm adding to it. When you multiply, we're gonna say, see if I did this right. 7 times 715 over 15,504 is equal to that 0.5942. And if I want, I don't know if it'll convert when it's in floating. Oh, it did. So it's 2303 over 3876. Generally in a problem like this, if it's a big fraction, you may or may not be asked to convert it, but if you are, that's what it is. 2303 over 3876. So this is 2303 over, oops, over 3576, I think I said. And that was, let me go back. And that came out to be 59 something, I think. Let me come back to the screen for a second here. 2303, 3876 and 5942. 3876. So we're 3876, not 35. So 2303
is gonna ask me to convert.
38. She may not on a problem like this. She may just ask you for the decimal. It depends on how complicated it is and how many problems it is. If generally her rule of thumb is she'll tell you in the instructions what she, just like she did on the quiz, she'll tell you like when she wants you to do all of it. I'm doing all 4 because I always get questions about how to do all 4. So I'm trying to address that by doing it here, because I noticed that even in some cases where she asks you to do all four, you don't have the answers for all four parts. So I'm trying to make sure that you guys have answers for all four parts of this. 5942. And then I think we have one more part to this question, which is all five from the US. So, yeah, let me just finish this because I truncated. 5942, and that means that this is equal to 59.42%. Let's do the last part of this question, which I believe is all five of them are from the US, or isn't it? Let me check. But I believe it says all five are from the US. So the last part of this is, yeah, all five are from the US. So we actually did this probability as part of the previous part of the question. So here, the probability that all five are going to be from the US. Okay, so we're looking at the probability of all five from the US is just going to be the number of ways to get. So this is the number of ways to choose five groups from the US over the total number of ways to choose five groups. So to choose five groups. So here we have the following. We're going to get, put it over here. So we're going to have, how many groups are from the US? Well, there are 7, right? So we're going to have 7 groups from the US, which are the 7 that are listed. And from that 7, we're going to choose 5. So 7 choose 5, which we calculated earlier. I'll go back and look. 7 choose 5. And then we have from the 13 that are outside the US, we're not choosing any. 13 choose 0. Okay. And at the bottom, the number of ways to choose 5 groups. Remember, we had a total of 20. And we're choosing 5. And we know what that is because we've calculated that. So this is just one of the terms from a problem that we already did. Questions about this so far?
No.
No? Okay. So let's take a look at that. So we have 7, choose 5. So we have 7, math, probability, and CR 5. 7 choose 5 is 21. And 20 choose 5 is 15,504. And remember, 13 choose 0 is just 1, but I'll do that here. So this is 13 choose 0 is 1. So we have 21 over 15,504. And we can reduce the fraction. So we're gonna go math, convert to frac. Oops. Math convert to frac. 7 over 5,168. And if I take 7 over 5,168, then we get 0.0014, or about 0.14%. So my screen share, it says it's paused. So let me put my numbers in here. This is 21. And this is 15, 504. So this is 15, 504. And that comes out to about 0.014, which is about 1.4. If I wanted the extra decimal, I'm not sure, let me check to see which one is, not that, I just want to see if it's, yeah, she rounded to 3 here. So this is 0.001. So this is about 0.1. So she just used 3 decimal places for that. You can use 3 or 4 depending on what she's giving you. Okay. 0.001. So this is and I copied this down. Let me erase that. This is 0.00. And that's about 0.1%. And so that is how you could put a 4 there if you want. But this would be 1.4 if you made it 4. She made it 3, and that's why, but that's how that one works. Shall we do number 6?
Yep.
Yeah, okay. Let's look at number 6 here. So we have number 6. Let's take a look. I think number 6, there's not as many. This is red and black socks. So a drawer contains 11 identical red socks and 8 identical black socks. Suppose that you choose 2 socks at random in the dark. Okay. So 2 socks at random, what is the probability that you get a pair of red? What are we going to do to get a pair of red socks for part A?
Minus or add?
Well, okay, before we get to how we do it, we have to choose a pair of red socks. So you can only choose red from the red. So how many socks are we going to choose from the drawer?
11.
No, there's okay, so this is where you're getting a little bit confused. When I ask you how many you're going to choose, that's how many do you remove?
Oh, 2.
Suppose that you choose, yeah, so how many are you removing? You're removing 2. You're choosing from the big pile of red. How many are in the big pile? 11. So here's how I figure out here's how I do it. I say, well, okay, I want, maybe this will clear it up a bit for you, because I noticed you've done that a couple of times. So here's how I do it. I say, well, this is, I've got a bunch of socks. So I've got 11 red, and I've got 8. What are the other color? 11 red.
8 black socks.
8 black ones. Okay, so I've got 8 black ones, right? That means I have a total of 19, right?
Yep.
Okay, now, when I want to find a specific probability of 2 matching red is what I want, right? So what I have to think about is the top of this is going to be the number of ways to get 2 red out of the pile of red, and nothing out of black ones, right? So I want 2 red out of the pile of red divided by the number of ways to get 2 socks, right? Because if I'm doing this in the dark or I'm asleep, then I'm not going to pay attention. So the number of ways to get 2 socks, right? So what I end up with here is from 11, because there's 11 red. So from 11, I choose 2. So I choose 2 red ones. And from 8, from the 8 that are black, I don't choose any. Right? Because I want them to be red. Now the bottom is easier, right? And I think the bottom is what you were trying to get me. The number of ways to get 2 socks, well, there's a total of 19. So the bottom is 19, choose 2. So 11 choose 2 times 8 choose 0 over 19 choose 2. So let's do this. We have this is 11, math, probability, and CR. 2, 11 choose 2 is 55. And from 8, we're not choosing any, math, probability, and CR, 0. Doesn't change it, it's 55. And then 19, choose 2. Is 171. So we end up with this. We end up with 55. This is 55 over 171. And then we're going to get our famous decimal and our percent. So this is going to be 55 over 171. And that's equal to 0.3216. I don't think that's going, maybe it does, but I don't think that reduces 55 over 171. I don't think the fraction reduces itself. Math, convert to frac. Let's see. Nope. So in that case, that is as reduced as it's going to get. And so we end up with, for part A, we end up with that. So this is equal to 0.3216, which is 32.16%. Okay. Now let's look at part B. What do you think you would do for?
Oh, I just did part B.
You did it, okay.
I got the right answer.
Good
This time
job.
it's just the same thing, but this time it's 8 choose over 2 and 11 choose over 0.
Yeah, that wasn't
So I
bad,
got-
right?
Yeah, so I got 28 over 171, and then I got 0.164.
Good job. How about C?
That I'm trying to figure out.
2 unmatched socks means one of each, if that helps you.
Okay, so
One of each.
it's the number of socks. Choose one.
Okay, so it would, are you doing the top or the bottom now? The top, right?
That's the top.
So from the red ones, how many red ones do you have?
11.
11, choose one, and what are you gonna do? What's the other term?
8 choose one.
8, choose one. What am I gonna do with both of those?
You'll multiply them together.
Multiply them to, very good. Very good. Do that and see if you get an answer that works.
Mhm. Mhm. Got the answer.
You got it? Got it to work?
Yeah.
Good job. Okay, a little free, don't overthink this. This is a kind of a play on a joke, and that's what the textbook author said. You know how if you've ever had a pair of socks, sometimes you lose one and you swear you don't know where it went, right? So that's what this is asking you. What happened? Because we should have 20 socks, not 19, right?
Oh.
Because there's 11 red ones. That should be 6 pairs, isn't it?
Yes.
But we're missing a red sock. Where did it go?
Oh, we got lost.
Where is my missing sock? So yeah, anything that you say it got lost or it got stuck in the washer, something like that. But it's a humor. It's kind of a humorous play. I'm not sure why it's in the textbook, but it's there. So she is not going to ask you that question. She may ask you how things are different, but she's not going to go for a humor play when you're doing it, but the textbook did. Okay. All
Mhm.
right. How about the next one? Let's look at the next problem here.
7.
You think so? Is that where we are? I think it is.
Yep. When
This
3
one,
dice are rolled, find the probability of getting a sum of 7.
a sum of 7. Now this, there you could break your head doing this. I remember the first time I tried doing it and I broke my head trying to do it and figure out how many outcomes there are. Okay. There's lots of ways to do this problem. And it's actually easier to think about a couple of things here when you're doing this, because I'm going to try and save us some headaches here. When you're doing, first of all, ask yourself this, because we haven't done this before, but we have all the rules to do it. So first of all, ask yourself, on 3 dice, not 2, on 3 dice, how many outcomes are possible for that?
Mm.
Okay, well, we have 6 outcomes on the first die, right?
Yeah.
We have 6 outcomes on the second die, and we have 6 outcomes on the third one. That's a total of 216 outcomes. Okay. Now, what I'm not going to ask you to do is try to make a sample space with 216 outcomes on it. You can, if you want, knock yourself out doing it if you want to, okay? But it's not necessary to do that. There are 216 outcomes. Then ask yourself this question. How many ways are there to get a sum of 7 on 3 dice? Okay, now that could be, I would suggest that you list these. Okay, there's other ways of doing it, but listing it is actually going to be the most straightforward and the least headache. There aren't as many as you think. You'd think there'd be a ton of them. There aren't too many. So if I get a 1 on the first die and a 1 on the second die, there'll be a 5 on the third die because I'm trying to get 7, right? If I get, and that really doesn't change this. Now, any order of these will still give me 7. So I would list all the possible orders of this that I can. So there's 1, 5, 1. And there's 5, 1, 1, right? Those are all the ways, if you have 2 numbers that repeat like that, that you can do that, right? Because I can put the 5 at the end, in the middle, or on the left. Okay. Now, another possible way to do this would be to get a 1, a 2, that's 3, and a 4, right? So now you have to ask yourself, how many ways are there to mix up those numbers to get 7? So I could do 1, 4, 2, right? You should have a total, if you do this correctly, you should have a total of 6 that are different. 1, 2, 4, right? Then I could have 2, 1, 4, 2, 4, 1. Or I could have 4, 1, 2. And I could have 4, 2, 1. Okay, so there's a total of 6 ways to get a sum of 7 from that group. Now, is there any other way to get a sum of 7 on 3 dice? Okay, well, remember you're working with the digits 1 through 6, but you have 3 digits, right? So could I do it with 3s? I could. I could do this with, I could do this with a 1, a 3, and a 3. All right, that would also be 7. Or I could do this with a 1, a 2, a 3, and a 2, right? 2, 2, and 3. 2, 2, 3. Okay. And those are the only way that I actually have a 4, 2, and a 1, but again, that's down here. That's with this group. Okay. So if you list all your outcomes here, again, this is kind of like the 151. There's only 3 ways of doing it. So this is 3, 1, 3. Or you could do 3, 3, 1, right? And then this is going to be 3, 2, 2, or 2, 3, 2, because you have 2 digits that are repeated. So if you add up these outcomes, you have 3 plus 3 is 9, plus 3 is 12, and you have 6 more here. So you have a total of 18. And I believe I counted them all. I don't think I'm missing any. 4, 1, and 4, 1, and 2. Okay, I did the ones with the 4s, so I think I'm good. 18, and let's see if it reduces properly. I didn't
Wait,
check.
what does it say? It says 16 values.
16?
Yeah.
I think there are 18. Aren't there? Did I count wrong? Let me see, because that could be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 and 9 and okay, I'm missing 1 because I have 15. So I'm missing 1 number. 1, 1, 5, 1, 5, 1, 5. It should be 16 over 216. Let me see if which one am I missing? 1, 5, 1, 5, 1, 1, 1, 2, 4, 1, 4, 2, 1. Oh, I listed 1, 2, 4 twice, though. That's
Now it
part
says,
of the problem.
oh,
No,
it's 15.
it's 15, right?
Yeah.
Is that right? Let's see if it would. I know what the answer is supposed to be. I just don't remember how many combinations there are. But I know it's, let's see, 15 over 216 is going to be math. Let's see. Math convert to frac. 5, yeah, it's 15, not 16. It's 15 over 216. So there's 15, and the reason is, I'll show you right now. I wrote this twice, and so I'll get rid of it in a second. But I wrote this one twice. Okay, so you only need to write it once. So there's only, I had 7 on this list. There's only 6 on this list, but we're going to get rid of that. So there's 16 values, or I mean, excuse me, there's 15. And if you reduce this, you get 1 over, or 5 over 72, which is so there's 15 choices here. Okay. But that's actually the easiest way to, but don't double count like I did. Okay. So this is going to be 5 over 72. And I don't, is it 0.06 something, right? 5 over 72. And this is, let me go back to my screen. This is going to be 0.0694. So I have, this is equal to 0.0694, and that is 6.94%. Okay, and I think we have a couple more left. Let's see.
8.
Let's see what number 8's about. So this is our percent there. Oops. I don't want that. I want my percent sign. Okay, let's take a look at it. See if is it something manageable or is it something nasty? Let's take a look. Well, let's see. So it says, okay. Find the probability that if 5 different sized washers are arranged in a row, they will be arranged in order of size. Okay, now this is not as hard as it sounds. They're different sizes. Okay, so here there's a couple of ways to approach this problem. I find it easier to do this without combinations, but you can if you want. You've got 5 different washers, 5 or 8, 5 washers. Let me remember, because I have 8 stuck in my head now. So we're doing 5. Okay, so we're doing 5 different size washers. Now, if they're different sizes, you can think of them as being distinct. That means that the order here will matter except for the first one and the last one. Okay, because if you're going from the smallest one to the largest one, then those ones in the middle, those 3 in the middle, have to be in a certain order, right? So if I think about the top of this, I have to think about, okay, let me show you this here. So if I say, I'm gonna say this, I'm gonna say, well, I have, so this is the probability that all 5 washers are arranged by size. Now, here's what happens with this. So we get the bottom of this is going to be the number of ways to put 5 washers. Okay, so we're looking at 5 washers, and here let me show you something here. I'm going to show you the difference between, we haven't done this for a minute, 5, and this is going to be math, but this time I'm going to show you something. I'm going to use the permutation key to show you the difference. This is permutation. 5 choose 5 is 120. This is when order matters, okay? And order matters here. So this is not a combination. It's because your order matters, because they have to be in terms of size, you're going to use a permutation here on top. You see that? 120. Now, we want them to be, that's going to be the bottom of our fraction, right? And either, because we either have to do this from the smallest washer to the largest washer, right? I have to use, I have to have either the smallest washer or the largest washer, which is 2, right? So 2, and I'm going to do math, probability, oops. So this is going to be 2, math, probability. So this is, but I use permutation this time. I need 2 permutations of 2 objects, meaning I need the smallest or the largest one. It doesn't matter how I arrange them, but I have to decide. So in this case, this is going to just be this. This is going to be, it's my screen share went away. Okay, so this is going to be 2 permute with a P this time. Permute 2 permute 2 over 5 permute 5. Now, the reason I'm using a permutation here is because the order makes a difference. Either I'm going from the smallest washer here, let's say this one, to a big washer over here, or I'm going from a big washer over here to a small washer here. So this 2 permute 2 on top is just reflecting that. Either I'm going from the smallest to the largest or the largest to the smallest. And I have 5 permute 5 because I don't have to set it up this way, but I have to have it this way to work. So this is going to be 2. And this is going to be 5 permute 5 is 120, as we saw. So this is going to be 1 over 60. And I'll let you work out the decimal and the fraction. That was the nuance for this question. Because once you establish what these ends are doing, these 3 in the middle, you know what they are. They become fixed. But there's 120 possibilities, only one of which is actually, when you reduce it, 2 of which actually fit your criteria there. Okay. Questions about that one?
No.
No? Okay, the other one that gives people problems is this last one with reading the material, because this last one is it's just a little bit odd. Unless you're into plants or biology, something like that, it might throw you off. All holly plants are dioecious. A male plant must be planted within 30 to 40 feet of the female plants in order to yield berries. Okay, so you have to have males and females in order to spread. A home improvement store has 12 unmarked holly plants for sale, 8 of which are female. Okay, so again, we're back to our 2 groups deal. Okay, now these are unmarked, so we don't know what we're buying. We know what was in the store, but we don't know what we're buying, and I'll show you that in a minute. So just for some context here with problem 8, or problem 9, I should say, we have 12 unidentified plants. Okay, we know that 8 are female. Now, here, some plants, it doesn't matter if they're male plants or female, they can still reproduce, but we need a male and a female. So here, I'm going to say that there's 12 minus 8, or 4 male plants. Now, here's our issue. Here's the situation. What we're going to do, it says, if a homeowner buys 3 plants at random, because they're unmarked anyway, I'm going to buy 3 plants, and I'm going to hope that I get berries. Okay. So I need to have berries. I'm going to buy 3 plants. Now, how do I get berries? Well, I get berries if I have a male and 2 females, right? Or 2 females and a male. But I have to have mixed plants to do this. Okay, I'm buying 3 plants. So here, this is, I have 12 plants. Now, to get berries, which is what I want, I need a male to be within 30 to 40 feet of a female, right? So I have 12 plants. I bought 3 of these plants. So choose 3. And I want to know, what is the probability of getting berries? Okay, the probability that you'll produce berries. Well, there's a couple of ways you can produce berries, right? You can produce berries if you have the probability of, remember, you're choosing 3 plants. So you're either doing 1 male and 2 females, or you're doing, or the probability of 2 males, let's see, 2 males, 1 female. Okay. Because that's really the only, because I can't have 3 of each. I mean, 3 of any one, right? So even though I would have more options than that, I only need these 2. So how do I find the probability of getting 1 female and Sorry, 1 male and 2 females. Are you there, Jason?
Yes.
Okay. How do I get the probability of one, if I choose it, how do I find the probability of 1 male and 2 females?
Uh, 4, choose 1.
Okay, 4 choose 1 would be 1 male. Okay, that's a good start. So we have 4 choose 1. That's our male, right? That means our other plant would have to be what? Our other 2 plants would be what?
8, choose 4.
Right. Well, not 4. How many plants are we
8,
choosing?
choose 2.
8. Yeah, 8 choose 2 is my, right? Okay, that's the first. So this is my 1 male and 2 females. What's the bottom part? How many plants total do I have?
12.
And I'm choosing how many to take home? Total. How many? I'm choosing 3, right?
Yep.
Okay, so I either have 1 male and 2 females, which is what you gave me here. From the 4 males, choose 1. And from the 8 females, choose 2. Or means we add, right? So we add, the bottom's going to be the same, 12 choose 3. All right. Now, what's going to happen in the other scenario? I'm going to have 2 male plants, 2 male plants, right? So here I need, how many males do I have altogether?
4.
4, choose 2 times what?
Times 8.
8, choose 1, right? Because I need 1 more plant. Then it's just a matter of working these out and adding them up. Okay. So let's see if it comes out. And I'm going to write a note while you're doing that. That this is, in other words, I need two males and 1 female, or 2 females and a male and 1 male to produce berries. Okay, so
I got 160 over 220 in total.
okay, so this is 160. And I think that will reduce, right? 220. That should reduce for you to 16, 8 over 11. Is that right?
8 over 11? I don't know. How do you know how to conduce?
To reduce, you
Yeah.
you divide the fraction. Let me show you that. So here it was a little easier because I know they both end in 0, right? And when a number ends in 0, I can divide it by 10. But this is what I did. I said 160 over 220, right? So what I did, you don't have to use 10. You could use a different, but what you're looking for when you're trying to reduce a fraction is a number that divides evenly into both. So what I basically did was I divided by 10. So if you take 16 and you divide, 160, and you divide that by 10, you lose the 0.
Oh.
You can try it on your calculator and see. Because when you multiply by 10, you add a 0 to the back. So 160 divided by 10 should give you 16, right?
Mm-hmm.
And 220 divided by 10 will give you 22, right? Now, I happen to know that both of these numbers are even, okay? And whenever you have an even number, that number you can divide by 2 without a remainder. So what I did was I divided by 2. Now this, obviously, if I'm using a calculator, and you're more than welcome to do that, we never say that don't use your calculator. We just say justify your work when you do. But this is how I did it in my head. 16 divided by 2 is 8. And 22 divided by 2 is 11. So I ended up with 8 over 11 as my fraction. Good work.
Mm-hmm.
Okay.
That's all of them.
That's all of them. I know your classmates will be so happy
Mm-hmm.
because there are no excuses on this homework assignment, because between this tutoring session and the other videos I posted, we did every single problem. So
Mm-hmm.
So we did every single problem, and I did that by design, because these are some of the hardest ones. This section, it's not, the concept is harder to think about. It's not, the math is not hard. The concept, thinking about how it's set up, that's the hard part. So there are more additional practice problems on the review as well. And the review is posted. And I
Yeah.
believe the solutions are posted still.
For the exam?
For the exam review.
Oh yeah, I did that. It has like it's like written in green on how to do it, or like similar
no, she
questions.
includes the so your exam will look very much like that. Okay. All right. Well, I need to go, Jason, but it was good seeing you. Thank you for stopping by.
Mm-hmm.
And good luck on your exam. Okay.
Yep. Thank you.
Take care.
Okay.
Bye now.
Goodbye.
I'm gonna have to. Oh yeah, I need to get up.